acid-base titration, but we'll look specifically not just at a general overview of acid-base titration, but specifically regarding strong acids and strong bases. And in the next video, we'll look at a different type of sequencing. For now, let's just look at what is titration. I'll just write this up here. Okay, what is titration? It's where the concentration, I'll put this here representative as concentration, so where the concentration of an unknown acid or base is determined, because we always have to find it out, so is determined by adding, this time, a known volume of a specific concentration of an acid or a specific concentration of a base, and then using a graph we try to figure out where is the point at which the equivalence point can be reached. Let's have a look at a few examples. Before we do that though, I do want to remind you here of what neutralization is. Now remember, neutralization is just when you have an acid in your junior grades plus a base creating a salt and water. Okay, so this obviously is water. So these two need to fully react. Pretty much every single mole, right? Every single mole of the acid and every single mole of the base need to fully react in order to create these products. So I'll just put here, they need to fully react all of their moles. So for example, I'm just going to put here on the side then that the moles of the hydrogen or hydronium, okay, should equal the amount of moles of the hydroxide. So when I mention that equivalence point, let me show you what I mean using a graph. So on this graph over here, I'll just put pH here on the side. 0 is going to be on the bottom, and of course we all know pH of 14 is going to be somewhere near the top. Maybe 13 will be just below that. Maybe 7 will be kind of in the middle over there. Make this a little bit bigger for you. Okay, so that would be 7. And then we're going to have to start near here on the bottom if we are dealing with an acidic solution. So let's assume, for example, we have hydrochloric acid, okay, already in solution. Okay, this here means solution, okay? So it's going to be somewhere near the bottom. Let's say maybe like 1, okay? That would be a good number here. So it's kind of starting at around here. It's extremely low pH. And as we try to figure out what this equivalence point was that I mentioned, we're just going to add a base titration. So let's figure it out. Let's add some base, and that's going to be something down here, right? So let's say, I don't know, volume of, well, what's a very, popular base? I think maybe, sodium hydroxide. Okay, let's say sodium hydroxide. Okay, and we're going to add that in. And then eventually, if we add this base in, of course, it's not going to stay down here. It's going to go upwards, right? So let's keep trying this out. So let's say we put like, I don't know, 25 milliliters here, and maybe like 50 milliliters here, and maybe there's like 75 here, etc. Okay, so let's start by adding some of this volume of NaOH. Okay, so this is going to slowly go upwards, right? It's going to slowly go up. And at some point, eventually, this is not just going to keep getting an increase of slope at this kind of rate. It's going to astronomically go vertical at some point. And let's say it hits that at like 50 milliliters. So it will just skyrocket up to here. Okay, so at this point right over there, at a pH of 7, okay, at that pH of 7, because obviously that's where the titration occurs, making it absolutely neutral, and all of the acids and all of the bases, their moles, right? So the acid moles of HCl and then the moles of the base fully react at that point right over here at a perfect amount of pH. So at this point, it is completely at an equivalence point. So here I'll just put it here on the side. Okay, this here is the equivalence point. And anything greater than that, so you add any more of NaOH, let's say you add like 51 or 55, okay, or 60, anything more past 50 milliliters, it's no longer going to be at this equivalence point of a perfect neutral amount of 7. It's going to start increasing again. Okay? And at this point, we have gone past the point of neutral and no longer acidic, but we are now basic, and we're going closer to, let's say, 13 or 14, which makes sense because at that point, we've added so much of this base that at this point, it is now basic here. Okay, it's no longer it's no longer acidic in this domain area. I just kind of want to put down here as a formal definition of the equivalence point. Okay, the equivalence point is therefore the point at which the amount of moles added is equal to the amount of moles present in the original solution. So in acids bases, it's very important for us to understand and revolve this around this concept of acids and bases, the point at which they completely react. I also want to add down here, there's another term you should know. It's something called the end point. Okay, so what is the end point? It's when we have an indicator changes color. So whether that's phenolphthalein, whether that's bromothymol blue, etc. Whenever this indicator changes color, this at this point means that the titration has stopped, because of course we've gone past the equivalence point. Now I want us to have a look at this question here, and I don't want you to use this in a way where you learned it in your previous grades of C1V1 is equal to C2V2. Okay, we could use that. However, I do want you to think about this in a more different kind of sense and use it as more logical as opposed to just formula. Okay, so what do I mean by equivalence point here? Remember, that's when you pretty much hit a pH of 7, okay, when they completely fully react, the moles of the acid and the moles of the base. So let's first divide this up into categories. So we have HCl on the side here, and then we have KOH on this side. How are we going to do this? Well, we at least know the volume of our HCl is going to be 3.4. Oh, sorry, not volume. It's asking for volume. Okay, so what volume? So for volume, I'll just put a question mark. And obviously, this stands for the molarity. So this is in moles per liter of HCl. So that's obviously our concentration. So we have 3.4 moles per liter. Will be required to reach the equivalence point. That's pretty much this one. They fully react. Okay, so fully react between the acids and the bases. And our KOH, our base, has a volume of 2.1 liters, and the molarity just going to be 2 moles per liter. Now, obviously, we could easily figure out what the amount of moles here would be based on our C is equal to N over V formula. You can just kind of do this in your head if you want. Okay, I'm just going to write it out for you. So C is obviously 2 moles per liter. And then we have our N, we have no idea, and then our V is going to be 2.1 liters. Obviously, we want to isolate for N, so you just do that. So that cancels out. You do it on the right side, you got to do it on the left side. So then what do you end up getting for N? I'm getting 4.2 moles. Okay, so we'll put that 4.2 moles over here. And remember, once we hit this equivalence point, this means that they fully react, okay, the acids and the bases. So if this base here is at 4.2 moles, that means this one here also needs to be at 4.2 moles. Okay, so if we want to isolate and figure out what the volume of our HCl is going to be, all you need to do is rearrange this in a way. So obviously we know C is equal to N over V, right? So this is going to be our C. Okay, this is our C is equal to N over V. I have no idea what it is. I'm just going to do that. Okay, obviously from here you can just pretty much cross multiply. So you just get your 3.4 moles multiplied by your volume is equal to this times this. So you get 4.2 moles times the liters. Let's just bring this up here. So we can pretty much tell that if we want our volume here to be alone, we got to divide this by 3.4 moles. Obviously these cancel. If you do it on the left side, you got to do it on the right side. So obviously we have 4.2 moles times our liter unit. 3.4 moles over here. Cancel these ones out. Then you just divide this by this. What do you end up getting for your volume? Get your volume as 1.24 liters. Okay, that's the answer. That's how you pretty much solve the equivalence point questions. Okay, so we're going to take a little bit of a backtrack now. Rather than hitting just the equivalence point, let's start figuring out how to solve these kind of questions before the equivalence point. Let's have a look. Beaker containing this many HBr, or hydrobromic acid. I'll just put it here on the side. Well, let's just convert it into our liters. We always want to convert it into liters. So we have, that's 0.03150 liters, okay? And in terms of its molarity here, its concentration is 0.015 moles per liter. Okay, and it's been titrated. Okay, so there's titration going on with this and our KOH. So let's put KOH here on the side. We have our volume here as, what is it, 0.02453 liters. In terms of our concentration, we have 0.012 moles per liter. Okay, it seems like we have all of our values here. Okay, so obviously we can easily find our moles values, right? So you just do C is equal to N over V on this side, so you just get 0.015 moles per liter is equal to our N, don't know what it is. Our volume here is going to be 0.03150 liters. Okay, so obviously you just multiply this on this side, these cancel, you do the same thing on that side. Okay, so what do you end up getting for your moles over here? You end up getting 4.725 times 10 to the negative 4. Of course, that's all going to be in moles, right? Because this liters and this liters cancels out, so you're just left with that mole. And then you can just do the same thing here. It's not going to be difficult. Try this yourself. You end up getting 2.9436 times 10 to the negative 4 moles. So I'm just going to erase this part. It seems like we have all of the values between these two. Okay, so there are no unknown values that we need to find. But how do we solve this question then? Well, read it. It says determine the pH of the solution at this point in the titration. At this point, okay, remember, we have to now figure out the difference between this and this, right? Because at this point right now in the titration, they need to have fully reacted. Okay, obviously we have a lot more on this side than over here, but at the point when they're equal, we have to figure out the difference then. So we have to now find the difference between this and this. So we're just going to do our little calculation over here, where we have our 4.725 times 10 to the negative 4. You subtract it by this one over here. And then we're going to eventually figure out what our difference is. I end up getting 1.7814. I think that's enough, times 10 to the negative 4 moles, okay? So we have to use what we just found as a difference, and we now have to plug it back into an actual C is equal to N over V formula. Why? Because we're eventually trying to find the pH, okay? And we should know in the previous videos, see the link in the description if you want to know more about the pH derivation. Link is in the description. this one over here is what we need to find, but obviously here would have to be our concentration. So whatever concentration we get, we can bring it up here, plug it into our little formula here, and then eventually we'll find our pH. So what we're going to do, so we're just going to get this one, plug it into here, but in terms of our volume, remember we can't just negate volume. We're literally dipping both of these acids and bases in the same beaker. Okay, we're putting them together, which means we can't ignore just one volume. Both of these volumes here need to be taken into account for. So we're just going to have to add these two and sum them up and then put them into our volume. So our concentration is going to be our moles up here. And we're going to have to divide it by our volume and put these together. And then what do we end up getting for our calculation? You end up getting 3.17936 times 10 to the negative 3. And of course, it's all going to be moles per liter, right? Moles per liter. Now we're just going to be plugging this back into this equation over here. So our pH is equal to our negative log of our answer. Okay, so this here is going to be our answer. This here is our answer, okay? So we're just going to be putting them in. What you end up getting for your pH? You end up getting 2.4976. Okay, this is your answer. For this question over here, we have our hydrochloric acid. That's going to be on this side. We have our lithium hydroxide. It's going to be on this side. What volumes? We're going to figure out the volume here. That is going to be our unknown. And our concentration over here is going to be 0.22 moles per liter of hydrochloric acid is needed to cause the pH of this amount of our LiOH. And of course, we're just going to convert that into liters. So that's 0.025 liters. And in terms of the concentration, that's listed for you. To have a pH that is equal to 7, okay? If this is what you pretty much see, you have to know that this is pretty much asking for when they are hitting the equivalence point, like we looked at in our graph. So obviously, whatever amount of moles has been reacted, it's going to be the same for both. So whatever amount of moles is here, it's going to be the same thing over there. How do we know that? Well, we know that this here, we have our two values out of the three. We could easily find our moles. So C is equal to N over V. So we have our C is equal to our N. We have no idea what it is. Over V, we have 0.025 liters. Obviously, just do it on this side. Cancel them out. If you do it on the right side, do it on the left side. So this cancels out, this cancels out. What do you end up getting for your N? 3.75 times 10 to the negative 3. Okay, so this is obviously all in moles. So whatever we have over here, it's going to be the same thing over here. So I'm just going to put N here also at 3.75 times 10 to the negative 3. Okay, so this is what we have for our HCl as well. Now, what is the question asking for? We just got to find our volume. So honestly, we have 2 out of the 3 values. So we could easily just plug them all into our equation. Okay, so C is equal to N over V. Right, so I'll just put 0.22 moles per liter is equal to N over V. That's this one over here. So obviously, cross multiply, end up getting 0.22 moles times our volume is equal to our 3.75 times 10 to the negative 3 moles times liter. Divide this by 0.22 moles. Cancel them out, do the same thing on the right side. So bring this over here. What does our volume end up becoming? Obviously these moles cancels out. You're gonna be getting 0.017045 liters, okay? So if you want to convert this into milliliters, we can. So just 1, 2, 3, so you get 17.045 milliliters. That's your answer. Alright, these two are the green questions of the day. This is the first one, this is the second one. Please pause the video, give this a try on your own, and I'll be giving you the answers shortly. This is the answer to the first question. This is the answer to the second question.